we are going to start looking at conic sections. So if you can see the pictures in front of us, notice those are cones. And depending on how we slice the cone depends on what type of conic section we get. And so you can see if we slice it here, we have a parabola. If we slice it this way, we're getting what is called an ellipse. Actually, that's a circle. This would be an ellipse. And then we have a hyperbola. And that was just one picture. And then the other picture also shows you, just in different colors, what those shapes would look like. We're going to be dealing with parabolas that face up, down, which we've already done, but also left and right. Okay, so let's look at these and let's look at a parabola, and let me give you a different definition than what we've looked at in the past. So in front of us is the definition of the parabola. And again, it's a little different than what we've seen before in the past when we've looked at the parabola. So there's a couple different definitions that we need to get familiar with. So right here, the definition of a parabola is a set of all points in a plane equidistant from the directrix and the focus in the plane. Okay, so for our parabola, you're going to see this point right in here. Our parabola shape always faces towards the focus. And so if we know where the focus is, we know which direction, and we know where the directrix is, we know what direction our parabola is facing. So this was just telling me that there's an equal distance from the focus. So this distance in here is equal to the distance from the point on the parabola to what is called the directrix, this horizontal line in this case. Okay, so those distances of those lines are equal. So the line passing through the focus and perpendicular to the directrix is the axis of the parabola and the line of symmetry for that parabola. And we've seen before that parabolas were symmetrical across that axis of symmetry. And so right here, this is just talking about, this is our axis of symmetry. Our axis of symmetry has to be perpendicular to this directrix. The vertex is the midway between the focus and the directrix, and is the point the parabola is closest to both. Okay, and we've dealt with the vertex before too. Okay, focus. Parabola is always facing towards the focus, and the parabola is always facing away from the directrix. So here's just another picture of what we were just talking about. And so any point that you choose on the parabola, there's an equal distance between that and the focus, and that and the directrix. So we could choose any point on here, find that distance to the focus. That would be the same distance from that point down to our directrix, where this is perpendicular. So right here, this would be the same distance from this point, our vertex to the focus, down to the directrix. So we could do that with any point on that parabola. Okay, so the standard form, or the form that a parabola can be written in, depends on which way it's facing. Okay. If it is the x value that is squared, I know my parabola is facing up or it's facing down. If it's my parabola that the y value is squared, I know my parabola is going to be either going left or right. So we're going to have different forms of this parabola. Let's first go back over here. Let's look at the third line. Okay, so if we have it in this form, we can tell what the vertex is. We can tell what the directrix, that line of the directrix is, and we can tell where the focus is. And so if we have the form of x minus h, quantity squared, this is equal to 4a parentheses y minus k. So if this is the case, the axis of symmetry is parallel to the y-axis. So that means that and the parabola opens up. So it's looking like this. And so we know that the vertex here, just like before when we had it in vertex form, this vertex is HK. And the focus, basically, here is our value, HK. We're going to just go up, right? If we go up to get to the focus, that's affecting our Y value, right? Up and down affects the Y value of our point. And so notice that the H value of our vertex is the same for our focus. So our focus is, the X value is H, just like the vertex, but to get up to that point where the focus is, we have to add this value of A. So it would be K plus A. That directrix, that line that's below, in this case is going to be a horizontal line. And we know that horizontal lines are always in the form y equals. And so our directrix this is in the form y equals. Well, we need to get down here. And it's affecting our y value again. And so that y value here is going to be the k value from our vertex subtracting A. So this is going to be K minus A. So you can see that these are already in here for us, but I'm kind of explaining how to get there. And that way you don't have to memorize these. If we know what way it's facing, we can determine how to get there. In here, notice they say that A is always positive. And in here, we have this 4A in here. And if that A is positive and there's not a negative in front, that's telling me that my parabola is facing upward. Okay, is there anything else I need to mention in this? No. So let's look at it going downwards like we've done before. So if we had a parabola facing downwards, we have our some vertex here. The vertex again is HK. The directrix is always facing away from the directrix our parabola is. And so if I was looking at this line again, the line is y equals. We're going up from our K value to get to here. So it is going to be K plus A is going to be the directrix line. And the focus, we're going to be going down A. So our focus is going to be at the point. Our H value is the same as our vertex, but this one is going to be K minus A. And notice in this formula here that we're looking at, this has a minus sign in front. So it's almost identical to the other equation. The only thing that's different is there's a negative in front. So this would be x minus h quantity squared equals negative 4 times a y minus k. Okay, so same sort of idea, but now looking at them as left and right. So if we're looking at this, and it's opening up towards the right. To me, if it's opening up towards the right, it's facing the positive x values. And that tells me that it's positive in front of here. The way I can tell again that it's going left or right is it's the y value that's squared and not the x value that is squared. So if we're looking at y minus k, quantity squared equals 4 times a all times x minus h. We're going to have a parabola that faces towards the right. Our focus, our parabola always faces towards that focus. Our vertex here is HK. This time though, to move that point from the vertex over to the right, we are changing the sign of our x value. And so to get to this point, and that distance is also a, and so to get to this focus, I'm going to have to add a to my x value of the vertex. So my focus in this case is at the point h plus a, comma k. The directrix, that is a line that the parabola is facing away from. And in this case, this is a vertical line. So remember, vertical lines are always in the form of x equals. And we can get to this vertical line, right? That's the x value. I'm going to subtract a from my x value of my vertex. And so it's going to be h minus a. It's my directrix. So one more, the other formula is when that a there's a negative in front of that 4a. So we have y minus k quantity squared equals negative 4 times a all times x minus h. If it's negative, think of it as the parabola is facing towards the negative x values. Again, you have your vertex. Your vertex is at HK. To get to our focus, though, it's that same y value, but the h value from our vertex, we're subtracting a to get to this focus. So it's going to be h minus a, comma k. The directrix, parabola is always facing away from the directrix. And this directrix is a vertical line. So it is x equals h, and this distance in between the vertex and the directrix is a. And so it's h plus a. So we might have to put it into this form. And if we have to put it into this form, then it looks like that we're going to need to complete the square to get these perfect squares that were on the left-hand side. So let's look at a couple of problems. Okay, so our example in front of us is y plus 1 quantity squared equals negative 4 all times the quantity x minus 2. And in here, it wants us to find the directrix, the focus, the vertex, and graph this. Looking at it when it's in this form, we can tell which direction it's facing. So looking at this, it's my y value, that's quantity squared. So I either know it's left or right, but it's this negative in front of this 4 in here. That's telling me that my parabola is facing to the left. I can look at where my vertex is. Remember, these are opposite. Okay, so my h value is 2, and my k value is -1. I need to look at my directrix, and I need to figure out what my value of A is. We talked about A always being positive. So, and this is always in the form right here as either -4A or 4A. We look back up at these. And so I know that -4A is equal to -4. So -4A equals -4. So I can figure out what A is by dividing both sides by -4, and I get that A equals 1. So I know I need to add 1 to my x value, and I need to subtract 1 from my x value to get these points. And so my focus, I would have to subtract A from my x value on my vertex. And so this would give me 2 minus A, and A was 1, comma, K, and K was -1. So my focus is going to be at this point of 1, -1. My directrix, well, that has to be the line. It's a vertical line, and so it's x equals . And I'm adding that value of A to get to that x value from my x value of my vertex. So if I'm adding 1 to this 2 of my vertex, and then K is the same. Actually, it's not a point, is it? So it's 2 plus 1. And so this would give me the vertical line x equals 3. This really doesn't tell me how wide this is. And so I might want to find some extra information to help me graph this. But so far right now we have that our vertex is at that point 2, -1. So I'm going to go to the right 2 and down 1. So looking at this and knowing that it's going to the left, excuse me, I can tell that it's going to cross the y-axis twice. I also can tell that it's going to cross my x-axis once. And so I'm going to have an x-intercept and I'm going to have a y-intercept. So let's find out what those x and y intercepts are. So if I'm looking for my x-intercept, I know that's when my y value is 0. So if we go back into my equation, y plus 1 quantity squared, but we plug in 0 for y, we get 0 plus 1 quantity squared is equal to -4 all times x minus 2. So let's solve for x here. We can solve for x by multiplying through by a -4. So on the left-hand side, we have 1 squared, which is 1, equals -4x, distributing that -4 times -2, so +8. Let's subtract 8 on both sides. So we get -4x is equal to -7. And dividing by -4, I get +7/4, which is 1 3/4. Okay, so I know at 1 3/4 is where my x-intercept is. We also know what another point is because of symmetry. And so I know that there has to be a point that's symmetrical to this. And so this is going to be 1 3/4. This went up 1, so going down 1. So 1 3/4, -2 would also have to be a point. And then let's find our y-intercept. So this is when our x value is equal to 0. So let x equals 0. And plug that into our equation. So we have y plus 1 quantity squared is equal to -4 all times x, which is 0, minus 2. And so we have y plus 1 quantity squared is equal to, well, -4 times -2 is 8. I could expand out this y plus 1 times y plus 1, but instead, let's use our square root method. It's already in that form that we can just take the square root of both sides. And so if we take the square root of both sides, we get y plus 1 is equal to plus or minus the square root of 8. Let's subtract 1. And at the same time, I'm going to pull out 8 has a perfect square, a factor that's a perfect square. So y is equal to subtracting 1, -1, plus or minus square root of 4 is 2. So I'm pulling that piece out. And then I'm left with a √2. Okay, that doesn't mean too much to me. I could kind of estimate, but let's use the calculator to help us estimate that. So looking at what is -1 plus 2 √2. And that's going to give us about 1.83. And then we're going to do -1 minus 2 √2. And that's going to give us approximately -3.83. So let's plot that. So we have this point here, approximately -3.83. So let's see right here. And we have this point up here, approximately 1.83. And so we have our parabola. Looks like this. Our focus, which we found, was -1, 1. I'm sorry, 1, -1. So that was right here. And our directrix was x equals 3. So that's a vertical line there at x equals 3. Okay, so we were able to find all the important information given that equation and graph it. So same directions. We want to find the important points, our vertex, our directrix, the equation of our I'm sorry, I said the directrix, the equation for the directrix, the point for the focus, and then we want to graph this. It's not in the form that we can tell what those things are, and so we need to put it in that form. I can see that the y value is squared, so I know that the parabola is either facing left or right, but I don't really know right now which way. And so first thing we want to do is we want to complete the square on those y values. And so we're trying to think about what we're going to add to both sides to make this left-hand side a perfect square. So we have y squared minus 2y. And so you're thinking to yourself, what is that same number we add to get -2? Well, if you half it, that will give you the same number that you could add to get -2. That's -1. And then that number that we multiply, we have to use -1 times -1, which is 1. So that 1 is what we're adding to make this a perfect square. And whatever we do to one side of our equation, we got to do to the other side. So let's also add 1 to the right-hand side. So this left-hand side is now a perfect square. So y minus 1 quantity squared is equal to 8x. And now we want to think of it as we're factoring out the 8. If you notice that those formulas, it was always 4p or -4p, and then that quantity was a coefficient of 1 in front of that x in this case. And so if we factor out that 8, which really looks silly, but if we factor out that 8, we can think of this as 8 parentheses x. And if you want, we can say plus 0. So we want to find out what h and k is. H is always with that x value, k is always with the y value, and we're looking at the opposite signs. So vertex in this case, our h value is 0, our k value is going to be 1. I notice that this is positive in front of that parentheses, so I know that my parabola, is going to be facing towards the right. I need to figure out what a is, and I know that 4a in this case is equal to this 8. So if I divide by 4, I know my a value is 2. Okay, so we're going to use this a value and our vertex, which is at 0, 1, to find our focus. And so we're going to need to add 2 from our x value to get our focus. So our focus, 0 plus 2, so 2, 1. Our directrix, we're going to have to subtract 2 from the x value of our vertex. It's a line, so it's in the form of x equals, because it's a vertical line, and that's going to be 0 minus 2, or -2. Okay, so let's plot what we have so far, and then we're going to find, if we need to, intercepts. So we had our vertex was at 0, 1. We have our directrix is x equals -2. Our focus was at 2, 1. We know our parabola is facing towards that focus. And so if you look at this and it's facing towards the focus, Notice it's not going to cross, well, it's already, our vertex is touching that y-axis. So all we want to find is that x-intercept, and it's going to just be 1, right? It's only going to cross the x-axis once. And so let's find that x-intercept. So we're going to let our y value equal 0. We can do it in any form. We can plug it into our original. We could plug it into our simplified form. Either way, we should get the same results. So plugging in 0 for y, this would give me 0 minus 1 quantity squared. Well, negative 1 quantity squared, that is 1, equals 8 times x. So if I divide both sides by 8, I get x equals 1/8. Okay, x equals 1/8. That's pretty right here. And so I know, I'm just estimating, not to scale. Also know where my symmetrical point is. It has to be the same distance. And so I see my parabola shape looks like this. And I can always, we could always plot more points. We could choose some value for x and solve for y. We would get 2 y values for that x value. Okay, so given the information about a parabola, we want to be able to find the equation. So we're given that the vertex is 3, 0, and we're given our focus is 3, -2. My suggestion is when you're given information about the conic section is to graph what you have, and that's going to help us with which equation we need to use. In this case, so our vertex is 3, 0. So I would go to the right 3 and not go up or down. And my focus is 3, -2. So go over to the right 3, down 2. So just knowing that, I know which way my parabola is facing. I know my parabola, then it has to be facing downwards. And so if my parabola is facing downwards, it's the x part that is squared. And so I know that my form is going to be x minus h quantity squared equals, it's going down, so there has to be a negative in front of this 4a, so minus 4a. All times y minus some k value. Okay, well, we're given certain information, right? We got the vertex. We know that h is 3, and we know that k is equal to 0. We also know where our focus is. And our a value, we add or subtract from our vertex to get there. And so that a value from 0 to -2, a would have to equal 2. So let's just plug in these values for h, k, and a, and then we have our equation. So we have x minus h, so x minus 3 quantity squared is equal to -4 times a, but a in our case was 2, all times y minus k, but k in our case is 0. So just rewriting this a little bit, this is x minus 3 quantity squared equals -8 all times y. So we found our graph, or our equation for our graph. Okay, so another definition was called this lattice, Let me just write it down. Latus, L-A-T-U-S. Rectum, R-E-C-T-U-M. It tells me that my length is always 4A, and it's the line segment that joins the 2 points on the parabola. That goes through the focus. And so it's going to be these 2 points in here. Well, we know that what the y value of those 2 points are. We know that that y value is -2. And so we could use the equation we just found and plug in -2 for y and figure out what x is. So let's do that. Let's plug in -2 for y. If we let y equal -2, we would get x minus 3 quantity squared equals -8 times y, which is -2. So we get x minus 3 quantity squared equals 16. So let's take the square root of both sides. So we get x minus 3 equals plus or minus the square root of 16 gives us back 4. Now, if we add 3 to both sides, we're going to get 2 separate numbers. If we add 3 to +4, that gives us 7. And if we add 3 to -4, that gives us -1. And so we got our x values in here. And so this parabola is much wider than I was thinking. So that's 4. And so we have these points here at -1, -2, and 7, -2. So our parabola is going to look like this. And I could get a little better with finding out what my y-intercept is by letting x equal 0. Okay, so we have a focus of -4, 4, and we have a directrix at y equals -2. And it asks us to find the equation of the parabola described, find the 2 points that define the lattice rectum, and graph the equation. Okay, so again, you want to plot what they're giving us, and that can help us figure out which equation that we're going to need, which way is our parabola going to be facing. And with the information they gave us, we should be able to tell that. And so if I plot that point -4, 4, I have a point right here. And if I look at the directrix, which is that line y equals -2. And so if y is equal to -2, that's a horizontal line. So if that's the case, I know that my parabola has to be facing towards my focus and away from my directrix. So I notice that my parabola is going to be facing up. Well, we need to figure out what the vertex is. The vertex is going to be the halfway point, right? Because it's the same A value going up from the vertex to get to the focus and down to the directrix. And so I know that my x value of my vertex h has to be -4. I just need to find the y value of my vertex k. Well, the halfway point between -2 and 4. Well, if I just think of that distance there, -2 to 4, that's 6. And so halfway of 6 is 3. So I need to go up 3 from my directrix or down 3 from my focus to get to my vertex. And so if I go up 3 there, that does me that my y value of my vertex k is 1. Again, it's facing up, so I know that my x values are the one that are positive. I'm sorry, squared, not positive. So it's x plus h or minus h, quantity squared equals, it's up, so it's positive in front 4a, all times x minus k, not x, y minus k. And so now we can start plugging in what we have. And so we have x minus -4. So we have x plus 4. Quantity squared equals 4 times a, but a is 3. So 4 times 3, that gives us 12. All times y minus k, and k is 1. So y minus 1. Okay, so we want to find these 2 points that have go through the focus and that the parabola goes through. And so think about what we know here. We know that those 2 points that the parabola is going through that we want to find are when y is 4. So let's y equal 4 and solve for x. So if we do that, we got x plus 4 quantity squared equals 12 all times y, we're letting be 4 minus 1. So we have x plus 4 quantity squared equals 12 times 4 minus 1 is 3. So we have x plus 4 quantity squared equals 36. Let's use our square root method, take the square root of both sides of our equation. And so we get x plus 4 equals plus or minus, well, square root of 36 is just 6. So if we subtract 4 on both sides, we get -4 plus 6 is equal to 2. Subtracting 4 on both sides, -4 minus 6 gives me -10. So my x values are going to be 2 and -10, and my y value we know is 4. So our points on the lattice rectum are 2, 4, and -10, 4. Okay. And -10, so -5, 6. Okay, and so this is where our vertex is, and it goes like this. I think we could also find it because when I was reading to you guys and I was saying that length of this line segment was in that, oh, I think I said it was always, let me read it back again. It told me that that length was always 4a. And so we found what a was, right? A was 3. And then if I multiply 3 by 4, that would be, say that that length is 12. And then I know that halfway, this is halfway, so I could have added 6 to my x value. -4 plus 6 would have given me 2. And I could have subtract 6 from my x value. -4 minus 6 would have given me -10. So that's another way we could have approached it to find those 2 points. But we found the equation and we found those points on the latus rectum, and we were able to graph this, given the information, just the focus and the directrix of that parabola. Okay, so this is the section on parabolas in our textbook in chapter 11.2. So let's take a break and then we'll come back and we'll look at ellipses.